part of 2, module 6 of our mathematics 10 applies the distance formula to prove some geometric properties. So our objectives are, after going through this module, you are expected to determine the distance formula and to determine the midpoint formula. Okay, so let's have now an activity. So use the number line below to find the length of each of the following segments and then answer the questions that follow. So we have given number line from -11 to +11 and given points, point A, point B, point C, point D, point E, point F, and point G, where point A lies on -10, point B lies on -6, point C lies on -2, point D lies on +4, point E lies on +6, point F lies on +9, and point G lies on +10. So what is now the length of each segment? So number one, we have segment AB. So what do you think the length? Okay, if your answer is 4 units, you are correct. So line segment AB is equals to 4 units. And line segment BC is also 4 units. And CD is equals to 6 units. DE equals to 2 units. EF is 3 units. And of course, FG is 1 unit. How did you find the length of each segment? So one way is by counting the number of unit or units. So let's count the number of units between point A and B. So we have now to count A to B. So 1 unit, 2 units, 3, 4. So it is checked that line segment AB is equals to 4 units. While segment BC, let's count. So 1, 2, 3, 4. So check that segment BC equals to 4 units. How about segment CD? So let's count. So 1, 2, 3, 4, 5, 6. So equals to 6 units, correct? And DE, at 1, 2, so 2 units, check. EF is 1, 2, 3 units equals to segment EF, and of course FG is 1 unit. Okay, so therefore if we're going also to find the length of segment DG, okay, segment DG, so let's count the number of units between point D and point G. So we have now count. So from D to G, so we have 1, 2, 3, 4, 5, 6. So segment DG is equals to 6 units. Okay. Okay, so what do you think the other way on finding the segment or finding the length of the given segment? Okay, so we have that other way by finding the absolute value of the difference of the two given points. So for example, in segment AB, while A is on -10 and B is on -6, so let's find the absolute value of the difference of -10 and -6. So to solve for AB, so it is equal now to the absolute value of -10 minus -6. So that -6 becomes positive, equals to the absolute value of negative 10 plus 6 equals to positive 4. So remember that in absolute value, the simplified form is always positive. So let's take segment CD, where point C is on negative 2 and D is on positive 4. So therefore, it is equal now to the absolute value of negative 2 minus positive 4. So it becomes the absolute value of negative 6. So therefore, it is equals to positive 6 units. Okay, so that are some ways on finding the segment or the length of the segment between 2 points. Actually, we have different ways. We have another different ways on finding the distance of between 2 points. So, gaya kanina, we have by counting. If the given points are on the numbered line. And we can use also Pythagorean theorem. If the figure satisfy the characteristics of right triangle. So we use the Pythagorean theorem, c squared equals to a squared plus b squared. And the other way is by using the distance formula, d equals to the square root of the sum of the quantity x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 quantity squared. So let's focus now on using the distance formula in finding the length of the segment. So example, find the distance between point P and point Q, where P is at 2, 3 and Q is at 10 and 8, using the distance formula. So it means that the coordinates of this point P is at 2 and 3, and this point Q is at 10 and 8. Okay, so you can assign either of the 2 points as your sub 1 and sub 2. So let's assign this point P at 2, 3 as your sub 1, and point Q, where point Q is at 10 and 8, as your sub 2. So it means that our x sub 1 now, x sub 1 equals to 2, and our x sub 2 equals to 10. So dito yan galing sa cube, x sub 2. While your y sub 1 equals now to 3, and y sub 2 is equals to 8. So all you have to do is to substitute to the given formula. So we have now d, the distance, is equals to, okay, so the square root of x sub 2, where x sub 2 is 10, minus x sub 1 is 2, quantity squared, plus y sub 2 is 8, minus y sub 1 is 3, quantity squared. Then after that, let's simplify. Okay. So let's simplify now. So that the distance now of PQ is equals to the square root of 10 minus 2 is 8 squared, plus 8 minus 3 squared is 5 squared. Or D is equal now to square root of 64 plus 25. So which is equals to the square root of 89. Okay, so we have now square root of 89 equal to 9.4. Okay, so that's now the distance, the approximate distance of P to Q. So this is 9.4. 9.4 distance from P to Q. Okay, so that's how to use the distance formula. So let us take another example. So we have that given triangle ABC, where point A is at negative 4 and 7, point B is at negative 7 and negative 3, point C is at 8 and negative 3. So find the distance AB, distance BC, and distance AC. So let's find first the distance of point AB, where it is given that point A is at negative 4 and 7, and point B is at negative 7 and negative 3. So let's assign this point A as your sub 1 and B as your sub 2. Okay, so substitute now to the given formula that D was to the square root of the quantity of x sub 2 minus x sub 1 quantity squared plus the quantity of y sub 2 minus y sub 1 quantity squared. So substitute is equals now to your x sub 2 now is negative 7. Okay. So it is now square root of your x sub 2 is negative 7. So negative 7 minus x sub 1 is negative 4. Okay. Close quantity squared. Plus y sub 2 or y sub 2 now is negative 3 minus positive 7 of x sub 2 y sub 2 squared or y sub 1. So let's simplify. So equals now to the square root of, so that negative 4 becomes positive 4. So negative 7 plus 4 squared plus negative 10 squared. We add negative 3 minus positive 7. So let's simplify. Was now to the square root of negative 3 squared plus negative 10 squared is 100, or equals now to the square root of 9 plus 100, which is equals to the square root of 109. And the square root of 109 using our calculator. And the square root now of 109 is equal to 10.4. So 10.4. So don't forget to write units. Okay. So that is the distance AB. So let's solve now for the distance AC. Okay. So where point A again, point A is at -4 and 7, and point C is at 8 and -3. So let's sign point A as your sub 1 and C as your sub 2. So therefore, let's show that x sub 2 is 8, x sub 1 is equals to -4, y sub 2 is -3, and y sub 1 is equals to 7. So substitute to the given distance formula that d equals to square root of x sub 2, quantity x sub 2 minus x sub 1 squared, that is sub 2. No? Okay, so ulitin natin. So let's substitute to the given distance formula that d is equals to the square root of the quantity of x sub 2 minus x sub 1 quantity squared plus okay, so the quantity of y sub 2 minus y sub 1 quantity squared. So substitute. So the distance now is equals to the square root of x sub 2 is 8. So 8 minus -4 squared plus y sub 2 is -3 minus y sub 1 is 7 quantity squared. So the distance now is equals to the square root of the square root of 8 plus 4 quantity squared plus -10 quantity squared. So the distance is equals to the square root of 12 squared, where 12 squared is 144, plus the square of -10 is 100. So the distance is equal now to the square root of 244. So the distance now is equals to in decimal. So let's use our calculator. So the square root of 244 is equals to 15.6. So the distance now is 15.6 units. So this is the distance from A to C. Okay? How about segment BC? Segment BC. So, segment BC. So, where point B is at negative 7 and negative 3, and point C is at 8 and negative 3. So let's assign point B as your sub 1, this is your sub 2. So therefore our x sub 2 now is positive 8, x sub 1 is negative 7, while y sub 2 equals to negative 3, and y sub 1 is equals to also to negative 3. So the distance formula is equal now to the square root of x sub 2, quantity x sub 2 is 8 minus x sub 1 is negative 7 squared plus y sub 2 is negative 3 minus negative 3 of y sub 1 quantity squared. So it becomes now equals to the square root of, it becomes now 8 plus 7, 8 plus 7 quantity squared, and this negative 3 plus negative 3 plus 3 quantity squared becomes 0. So it becomes 0. So equals now to the square root of 15 squared, where the square root of 15 squared equals to 15. So the distance now of B to C was to 15 units. So that's how to find the distance between two given points. Okay, so let's talk now about midpoint. So the midpoint formula between 2 points, if point L is at x sub 1, y sub 1, and point N is on x sub 2 and y sub 2, are the endpoints of the segment M is the midpoint, then the coordinates of the midpoint is equal to x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. This is also referred to as the midpoint formula. So if we talk about midpoint class, it is not a distance, no? It is a point between, or the middle point between the two given points. So point L is at, let us say it is at 1 and 2, and point N is at 9 and 10. So we're going now to find the midpoint of these 2 points using the midpoint formula. So let's rewrite again that L is at 1 and 2, while N is at 9 and 10. Okay. So the same, you can assign any of the 2 points as your sub 1 and your sub 2. So let's assign L as your sub 1 and N as your sub 2. So it means that our x sub 1 now is equals to 1 and x sub 2 is equals to 9. While y sub 1 equals to 2 and y sub 2 is equals to 10. So using the midpoint formula, the midpoint formula says that it is the coordinates of x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. Okay. So let's substitute. So the coordinates now of the midpoint are x sub 1 is 1 plus 9 over 2. And for the ordinate, we have y sub 1 is 2 plus 10 y sub 2 over 2. And so therefore, the coordinate now of the midpoint is equal to 1 plus 9 is 10, divided by 2 is 5, and 2 plus 12, 2 plus 10 is 12, over 2 is 6. So it means that the midpoint of this, or between point L and point M, is at 5, 5 and positive 6 dito approximately. So this is 5 and 6. Okay? Okay, so let's take another example. The coordinates of the endpoints of segment LG are negative 3 and negative 2 and 8 and 9 respectively. So what are the coordinates of each midpoint? So it means that point L, the coordinate point L is at negative 3 and 2, negative 3 and negative 2 rather, and point G is at 8 and 9. Okay, so let's assign point L as your sub 1 and point G as your sub 2. So therefore, your x sub 1 now is equal to negative 3, while x sub 2 is 8. Your y sub 1 is negative 2, and y sub 2 is equal to 9. So let's substitute to this given formula of the midpoint. So M now, or the coordinates of the midpoint, is equal to x sub 1 is negative 3 plus x sub 2 is 8 over 2, and for the y sub 1 is negative 2 plus 9 over 2. So let's simplify. So the coordinate of the midpoints is equal now to negative 3 plus 8 is 5 over 2, and negative 2 plus 9 is 7 over 2. Or in decimal, it is equal now to 5 over 2 is 2.5, and 7 over 2 is 3.5. So this is now the coordinate of the midpoint of segment LG. So let's locate 2.5. So 1, 2.5, and 3.5. 1, 2, 3. So 3.5. So this is the midpoint now of between point L and G. X at 2.5 and Y at 3.5. Okay, so simple as that to find the midpoint between two given points. How about this? So this time we're going to find the distance and the midpoint of the given points. Okay, but first we are going to find the coordinates of point P and point R. So point P Let's try. So 1, 2, 3, 4, 5, 6, 7. So this is negative 7. This is 1, 2, 3, 4, 5, 6. Ulit. 1, 2, 3, 4, 5, 6, 7. This is positive 7. So therefore, the coordinate of point P is at negative 7 and 7. Okay. While point R is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. And 1, 2, 3, 4. Hindi siya nagkapareho ng ano. So this is negative 4. Okay, so the coordinate of point R therefore is at 9 and negative 4. So let's find first the distance. So the distance, given the distance formula, where P is at negative 7 and 7, and R is at 9 and negative 4. So the distance formula was now to the square root of quantity x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So if you assign P as your sub 1, R is your sub 2, so therefore your x sub 1 is negative 7, while x sub 2 is equals to 9, y sub 1 equals to 7, and y sub 2 equals to negative 4. So let's substitute. So it equals now to the square root of x sub 2 is 9. 9 minus x sub 1 is negative 7 squared plus y sub 2 is negative 4 minus y sub 1 is 7 quantity squared. So it's equal now to the square root of, it become 9 plus 6 is 16 squared plus it become now negative 11 squared. Negative 11 squared. Or it's equal now to square root of, so 16 squared so 16 squared now is equal to 256 plus 11 squared is 121. So add natin 256. So it is now the square root of 377, or the distance now is equals to, what is square root of 377 equals to 19.4 approximately. So that is the distance peak R. Okay. So how about the midpoint? So the midpoint now is equals to x sub 2 is 9 plus x sub 1 is negative 7 and over 2, and y sub 2 is negative 4 plus 7 over 2. Okay. So the midpoint now is 9 minus 7 is 2, over 2 is 1. And negative 4 plus 7 is positive 3, over 2 is 3 over 2, or 3 over 2 is 1.5. Positive 1.5. Okay, so this is the midpoint of the two given points. So 1 and 1.5. So andito yung midpoint niya. So this is 1 and 1.5. This is the midpoint of segment PR, or the midpoint between point P and point R.